Video.
Sorry, sir.
Do you want to switch on your video?
Yeah, can I switch on, sir?
Yes, yes. Why
Okay,
not?
okay.
Yeah, please tell me your feedback.
Sir, sir, actually, I am working in nonlinear dynamics, sir. After this workshop, I
Okay.
came to know. After this workshop, I came to know the nonlinear dynamics that frequency response curves also
Hmm.
used in the different fields in the mechanical
Yes.
system, the MEMS and NEMS. Those things I got new ideas, sir.
Okay.
Actually, I completed MTech Nanoscience also.
Hmm.
In that one subject I took as NIMS and MEMS.
Hmm.
That time I have some idea about the NIMS and MEMS, but now I came to know this nonlinear dynamics is very useful for understanding the NIMS and MEMS devices.
Yeah, right. Because the thickness of these devices are very small, so
Yes,
that
sir.
even for the small loading, electrostatic loading, it can cross. The deflection can be more than the thickness, right? So it may
Yes,
go into the non-linear immediately sometimes.
yes, sir. Yes, sir. So
While
we
for
can,
the bigger structure, it will take time to go into non. It is very difficult to bring the system to non-linear oscillation. But
yes, sir.
yeah,
Yes,
yes.
sir. Sir, but from that history loop, we can control the that vibrations and all that. It is quite
Hmm.
interesting. The one sir
Right,
is
right.
teach
I
from
think
his.
I think you have been working. You have been sending some messages to me related with this, right?
Yes, sir. Yes, sir. That
Yeah.
time
So
actually
that
we
is the
asked some.
reason. That is the reason why I posted this workshop detail on Facebook so that you come to know.
Yes, sir. Yes, sir. Through your Facebook only, I came to know you are conducting this
Right.
workshop. It is very useful for me, sir.
Very very nice to see you also, and
Okay, sir.
hopefully I've got, because in the fluid dynamics and the last two lectures were mostly the special lecture, and where you see that there is a deformation stress strain non-linear like how to characterize them, how to get those curves experimentally. So I thought that exposure of that kind would also be very beneficial.
Yes, sir. Actually, yes, sir. Many nonlinear oscillators also people are using in study the nonlinear plasma oscillation also, sir.
Mm-hmm. Okay,
Okay, my
I see.
major work is plasma oscillation,
I
understand by
see.
the cupping oscillators.
I think Schrodinger equation also they are solving.
Yes,
Yeah. Hmm.
okay, thank you, sir. Thank you so much.
Thank you, Jay
One day
Prakash, and nice
one
to.
day I'm interested to come to your lab, sir.
Oh, please come sometimes after this
Okay,
Corona go over.
okay, okay, okay,
Yeah,
sir. Thank you so
right.
much.
Thank you.
Thank you, sir.
Thank you, Dr. Martin, for submitting. Would you like to say something?
Good afternoon, sir. This is
Good
Martin.
afternoon. Good afternoon, sir.
So I'm from PhD College of Technology, Coimbatore, sir.
Okay.
Actually, I'm not
Would
interested in
would
attending
would
this.
you like to open your
Sir,
camera,
my
or you want
camera
to?
is out of order, sir.
Okay, okay, no problem. No problem.
Actually, I wanted to attend the course specifically at IIT Hyderabad, sir. So
Okay.
before 2 or 3 times, some other courses related to same domain happened,
Ah,
but I'm not able to attend those courses. But
I see.
somehow during this period, COVID period, I am able to attend. But I am not
Hmm.
satisfied because there is no personal interaction with resource
Yeah,
persons.
yeah, yeah.
So,
Right, right, right. Yeah, that
uh,
is missing.
as a dynamic, and they used to give so many informations to us. So very
Hmm.
interesting, very the way they are taught and discussed are very interesting, sir. So thanks
Yeah,
for all
thank you.
this given. So whenever again the course is again going for second time
Yeah,
after, so after the
yeah.
pandemic, definitely I will
Right.
visit
Sure,
Hyderabad.
sure, sure, sure. Yeah, we will plan, because it looks like many. What we will also do it, we will in touch in this group, because it looks like many of you are interested in nonlinear dynamics and then exploring it quite seriously. So maybe later on like non-linear kind of, there are many societies, non-linear mechanics society or dynamic society, but we can always plan to have some workshop or some talk related with this,
Yes.
where we can invite some expert in the field, and then I will send invite to all of you, and in case you are free and want to like attend, you can always do it.
Yes. Thank you, sir.
Yeah, okay, thank you so much. Yeah, Dr. Panda, yeah, you have to just submit, click the submit button at the end, which is at the bottom.
Hello, hello, sir.
Hello, Dr. Panda, how are you?
Sir, when I am submitting, there is some icons of icons are coming.
Yeah, so you have to, there is a submit button, I guess, at the end that you will have to click, which is at the
Then
bottom, ekdam extreme
then
bottom.
then verify some things are there in the bottom. There is a bridge. Then ऐसे कुछ image आता है.
Okay, I don't know why it is coming.
Anyway, that image you have to check light, table, car, or everything you have to do. That you have to verify you are not robot.
Oh, I see, I see. Is it coming like that?
Yes, 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 it's coming.
Oh, yeah, so you will have to verify and then submit. Yeah, would you
What are
like to
the
say something, Dr. Panda?
sir? Sir, this is a very informative session. I know about so many things about the MATLABs
Mm-hmm.
and that softwares
Yeah.
and that. Then your session is very informative.
Yeah,
Sir,
thank you. Yeah.
sir, what are you doing now? I check all the things, my email ID and my name, ending time.
Don't worry, you take your time and end it. I have a control over here. So you can continue doing it. You just try it out again.
Submitting not. I'm not trying the submitting, but not that.
Thank you, Dr. Panda. You can try it and just see how you can do it. Yeah, Dr. Jay Devan.
Yes, sir.
Yes,
Good
sir.
evening.
Yeah,
Good evening.
thank you.
Good
I
evening,
have
sir.
been receiving your message and your curiosity. It's very interesting. Yeah.
Sir, I am working in experimental fluid dynamics.
Acha, okay.
I am a total alien in this region, this nonlinear
Okay.
analysis. Okay, the first time I am attending a course on that. Yeah, because I have some curious observation in my experiments I have done in my PhD time. It's over quite 2 years ago, but I could not solve that with linear techniques.
Okay.
So, and there is no facility to do this flow visualization also. So I just want to start this work in this perturbation techniques, and I just want to think in out of box thinking.
Okay.
I should tell that. Okay, that
Yeah.
is why I attended the class. This one to get some introduction.
Okay.
This and get an entry so that I can develop this, get some good books. Told by the faculties. And
Right.
it's really interesting section.
Yeah.
Except the quiz. that I don't know.
So,
Quiz,
Harish,
it's really
you must have enjoyed Harish talk because
really yeah,
his
Harish sir,
field
yeah,
is
thank you sir.
like yours,
Good
right?
evening, sir.
Good evening.
Yes, sir. Hello.
Yes, sir. Please tell me.
Hello, sir. Are you listening me?
Yes, sir. Yes, Amrendra, sir. Please tell me.
Sir, I am, sir, myself, Ambind Kumar, sir. I am pursuing PhD in a robust control system. Generally, control theory is my core subject, but
Okay.
my background is electrical engineering in power system. So, electrical engineering comprised of the two systems. The first one is the power system, and the second one is the control system.
Right.
And sir, in control systems, I have the first of all, I would like to say about this FDP that this FDP was really marvelous. Is really
Thank you.
is great. As much as appreciation is just for this FDP. But sir, I have found some shortcomings in this FDP.
Yeah, please tell me.
Just orange attractor and the chaotic behavior of the nonlinear systems, and the solution technique of the nonlinear system was only demonstrated on the basis of the perturbation technique. While there are in the industries, whether it may be electrical, aerospace, or mechanical, or since I am unaware unaware about the fluid dynamics.
So just
the solution technique, just like the solution by the linearizing the non-linear systems by the y derivative.
Right.
Y
So
algebra.
like if you remember, there are equations in like controls and electric circuits which gives us nonlinear equations. So basically, from like I have friends in electrical who work on this stability theory, nonlinear stability analysis also, and exactly in power, power and controls that you are mentioning. So and bifurcation analysis also they do. So
generally in voltage stability, in rotor angle stability, generally it is control system is and the nonlinear dynamics is a part of the system theory. So it is the universal, it is the universal engineering that a common man can see around his ambience. It's just like in the climate, in the wave, in the ocean, in the it's spectra. So it was really, sir, unprecedented the qualities of the and the content of your delivery.
Thank you. Actually, there is a new technique which is coming up. This SM tool that I wanted to have it in the session 15, but somehow that guy had some problem in his family and he couldn't attend. So that problem, that technique is quite robust and it looks like it is, but I think it will take some time before it spreads to other masses. Our intention was that we realized that not many people use matcont or other bifurcation tool or maple and all that for doing nonlinear analysis. So we thought that why not just give exposure. We can't really teach in a day or two, but at least to tell them, see, here are the platforms that you can use, and you can do many things, because maple or mathematica that you use to solve bigger expressions, and then using MATLAB you can do numerical simulation, and matcont, auto, or other bifurcation tools, you can generate many complex nonlinear orbits and these envelopes. So that was main idea, and then we thought that okay, let us pull some fluidic guys and then nonlinear.
And so another thing I want to say that in this FDP, generally the solutions of the problem was undertaken by the state space model of system dynamics.
Yes.
But in recent advancement, there is the modeling is shifting towards the state space to energy based modeling.
Exactly.
That is passivity based PCB port connected Hamiltonian system models. And it's so I have seen the various paper, and the passivity is the emerging a very informative and promising tool in the solution of the nonlinear stability. I think those things was missing in this
Okay.
FDP, the
Okay.
passivity. And
Yeah.
in passivity, you will aware about the Casimir equations. So that was the, it means I want to say that general control theory, the advancement in the control theory,
Yeah. Yeah.
the phenomenon associated with the nonlinearities was greatly described,
Yeah.
but the general control theory advancement was some about lagging.
Okay. Yeah. Right. So, your comment on this energy approach. So, basically, these equations whenever we apply to, for example, the beam vibration or other system. So, we start with energy only, and from there we reduced our equation to this reduced order, so that we can apply this perturbation method. So before applying perturbation method, we require to bring the form of the energy to that like a given form, such that it can be applied. So most of the presentation, you will see that we didn't describe how to convert it from energy to that state space, but we started from the state space and then explained the technique. Yes, you are right. I think there should be a session over it, and uh, it is really essential. So next time we will keep it in mind. Thank you, Dr. Amrendra. Anybody else? Neeraj ji? Yeah, thank you, Karthik. Yeah, Dr. Ramakant.
Yes, sir, this is Dr. Karthik.
Yeah.
Actually,
Dr. Karthik. Yeah.
everything the theory part, can I speak?
Yes, please.
Actually, some people join. Okay, actually, that we have learned a lot of the theory part as a basic. We have, who are working in a fluid elastic instability or this related nonlinear area, they know very well. But hands-on experiment with software, it will be more helpful, because
Right.
throughout the session, one more thing, from morning to evening, listening to the theory, and this part is a little I am saying, little somewhat I felt little tired in a manner. In for
Right. I agree. And that too online.
yes, that is a difficult thing.
Yes.
Apart, if you work on some real time, actually nowadays everything moved toward the virtual one. If you work on some software oriented, some examples oriented, like if you done in institute, it will be a more good, because
Yes.
sitting here more distraction will be there. Obviously,
Right.
you know the fact.
No, we will definitely do just dedicated session on the software, only hands on. So that like 80 to 90% of this transfer of knowledge happens.
Yes, sir. Actually, the MatConf and Maple you have told, somewhat it is like near to me, because we are using like fluid structure, and we used that OpenFOAM Fluent and other different software. When we come to non-linearity, it is a new part of work.
Right.
So that someone is.
Right.
Actually, that hands-on experiment, it will be more knowledgeable, because I want to explore in this field. Apart from that work which I have done earlier, so at a certain saturated level, so it's a thing start for my new approach toward the nonlinear in different orientation. The nonlinear application in every field, so everything is there.
Okay.
So it's a good workshop, and you can start a second enhancement of two, like
Advanced level.
Advanced workshop you can conduct. That is my suggestion, and very happy for that. Anyway, the questions are little somewhat very basic and somewhat little confusing manner, but okay, we have a.
Thank you so much. Thank you. Yeah. Anybody else? I think somebody. Doctor. Yeah. Noya.
Sir, good evening. This is Noah from Vellore.
Okay.
From Vellore. So I am from the Department of Physics. So
Okay.
all of these sessions was completely different to me because I could see everything in the engineering point of view. So
Right,
it was
right.
a good exposure for me to
Okay.
have this. And with regard to the packages that you have used, as far as I have heard, so I'm just a beginner in this
Okay.
nonlinear dynamics field.
Okay.
So I have heard that people who are doing research, especially physics people, they use Fortran and Python
Yes, yes.
languages.
Yeah.
So the
Auto.
mathemat.
You can use auto, which is written in Fortran.
Okay, okay.
Yeah.
But they use Fortran itself just to, and they do the mathematical modeling, and
Okay.
then the solutions and the plotting, everything is done using those languages.
Okay.
So this was another perspective to see how solutions are being obtained using different packages.
Yeah.
So thank you.
Thank you.
I am actually working on the aspect of synchronization. Most of the things that you have discussed here, so it was like as I said earlier, mostly related to engineering. So I am just thinking of working in biological networks, the idea of
Okay. Okay.
synchronization, things
Okay.
like that.
Okay.
Maybe if you have something to share with me, you can do, and I can get you in
Sure.
touch.
Sure. Sure. Sure.
Thank
Yeah.
you.
Thank you. Thank you so much.
Yes.
Thank you so much. Yeah. Anybody? I think I'll just see.
Yes.
Yes,
Hello.
sir.
Yeah. I'm Raghavendra Naik from Goa Engineering College.
Okay.
I'm
Hi.
assistant professor there.
Yeah.
Yeah. I would like to know about experimental analysis in MEMS. What will
Hmm.
happen? There will be like geometric nonlinearity, which will
Yes.
play a very big role in that,
Right.
and
Right.
also very high frequency like RF means there will be a lot of means nonlinearity will play a major role.
Right. Right.
Because what I have is like only theoretical knowledge. But is there any
Hmm.
experimental method where we can actually characterize
Yes.
these
So,
nonlinearities?
so I will tell you, to get the experiments, you need a couple of things. So you take oscilloscope, and you should be able to. We have vibrometers. There is something called laser vibrometer, so which is used for dynamic characterization of these MEMS devices. Alternatively, you can just buy one uh, laser source, and then PSD, through which you can capture the signal, and position sensing device is a PSD. So which is like which is having piezo patches around it. So when from so let us say uh, this is your piezo, okay, and you are putting your device here, and I have a laser source like a pen. I'll just direct it here. I will apply signal electric voltage to it, and it will oscillate, and then it will go there, and we have a PSD which will be here that will measure the response. So when you excite this one at a higher voltage by varying frequency, so you will be getting different time signal. Okay, if you are, let us say, if you are having oscilloscope, you will be getting different time signal, and from that time signal or time history you can plot this frequency response, nonlinear frequency response.
Okay.
That is one and simple, like low cost technique that you can use it. Second is there is, other than oscilloscope, you can use network analyzers, or spectrum analyzer. Okay, so network spectrum analyzer, what it does, it gives you the spectrum response over the spectrum of frequency, and from there you can get your frequency response in the forward sweep, this nonlinear response, very easily. Okay, but if you want response in forward and backward sweep, there is third kind of device which we call as lock-in amplifier. Okay, so lock-in amplifier helps you to basically it basically works based on the phase phase measurement, and what it helps is it will help us to do sweeping from forward and also backward. So when you do forward sweep, you will have one jump, right? And when you do backward sweep, you can get your another jump also. So that way you will be able to capture the hysteresis in the response, nonlinear response function. So for the measurement, one is oscilloscope, network spectrum analyzer, a third one is lock-in amplifier. So with oscilloscope, from time signal you can get both. That is little bit hectic because you will have to take that many time series over different frequency. But network, you don't have to do it individually. It will just sweep it, and you will just fix it, the time period over which the steady state is reached. It will draw the FFT, but you can't do reverse sweep, reverse kind of. But lock-in will help you to do both forward and
Okay.
yeah. So with the help of this, you can do this experimental measurement.
Thank you very much.
Yeah, and we have MEMS vibrometer. So in case you have devices and you want to do measurement here, you can come. We have for other institute, we have opened it. There are some minimal charges that the institute take, and so you can do the measurement based on that, and then you can take your result along with you. And we are not interested in any co-authorship on any kind of. So because it's your work, and you should be the only thing that is better, that because for the maintenance of the equipment, we just charge very minimal amount for per day basis. Yeah. Okay, thank you.
Thank you.
Yeah. Yes, Dr. Rao. Thank you, Dr. Parimila.
Sir, it's Jay.
Yes.
Sir, is there any optical profilometer available in IIT Hyderabad?
Yeah, there are. So I will just send you one link. Okay,
Okay,
there is a
sir.
link here that you can refer, and which is all the equipments are available.
Okay.
Yeah.
So we get a prior permission.
So you will have to contact the faculty in charge of
Okay,
that.
great.
So here is the facility. I'll just give it to you in the just here. I'll type.
Chat box.
Yeah, in the chat box. Okay, so if you click this, you will get many equipment, and
Okay.
they are open for the
Okay.
institution to use it. And yes, there are some minimal charges associated with that.
Okay, sir.
Yeah. Yeah, and also, like as on the first day, Professor Ramji was saying, we are going to start some online MTech program for basically for industry guys, working professional, which will be for 4 years, and the classes will be held in evening. So like we are going to put out the advertisement very soon, I think today or tomorrow, and last date is end of this month. So if you have any friends who want to do, so one is in computational mechanics, another one is in electric vehicles. So if somebody is interested, you can always tell them. Yeah, related with this uh, workshop is somebody else. Delcy, you want to say something? Yeah,
Sir,
Jay, yes.
sir, in MEMS fabrication, what are the facilities are available there, sir?
So in MEMS fabrication, we have RF sputtering, then thermal deposition,
Sir,
and
etching is available.
etching is there. The E-beam lithography is getting installed, but wet
Okay.
etching is possible with Prem Pal. There is a Professor Prem Pal in physics department with whom I do work. So yeah, he does wet etching. So if you want to fabricate a structure out of silicon oxide or nitride, so he will be able to help you.
Okay, thank you, sir.
Yeah.
Thank you so much.
Thanks.
Sir, when will you update the marks and attendance?
Yeah, just now. The moment I like we are done, I will release the marks, and it will
Okay,
come
sir.
to your email ID.
We are expecting your gracious mark.
So this is as you know that it is Google form. Google
Yes,
does calculation on its own.
Okay, sir. Whatever it is, but it is a good experience. Okay,
thank you so much. Thank you.
Okay.
Yeah. Anybody? Anybody would like to share something or would ask something related with this course and how you like us to like there are very good suggestions from Dr. Karthik and then Dr. Amarendra and others. We will definitely try to be more focused towards the like tools so that you appreciate at the end of the day that you have done it. Right now we have just exposed those tools to you, but next time we will try to conduct a session such that you should be able to come out of this workshop and should be able to start working in this area straight away. So that's very good suggestion. Anybody else? Dr. Jitu, thank you very much. Dr. Vijay Kumar, thanks a lot. Dr. Anir Anandu, yes, thank you. So, anybody would like to share something? Okay, so if not, so I take this opportunity to say final goodbye to all of you, and please take care of yourself and enjoy your life. Don't be in stress. And I'm sorry that I just put you through this online business for last 5 days. And please take care of your health. Thank you so much
Take
for
care of
registering with
Thank
me.
you, sir.
Thank you. Thank you.
Okay.
Bye bye.
Thank you, sir.
Bye
Thank you
bye.
so much, sir.
Bye bye.
Thank you, sir. Thank you, sir.
Sir, it is not a final goodbye. We are expecting more.
Sure, sure. Sure, sure.